Okay, so now for AC method. So AC method gets its name from this. We have our trinomial here. We have A and we have C. So the second method for factoring trinomials of this type is known as AC method, and not only involves trial and error of FOIL, but factoring by groups. Now, the AC part comes from what we're going to do. It's going to be very similar to what we were doing with trinomials when A was 1. Is that we're going to multiply A and C together and find out what that is. That we're going to find factors for. So when we do AC method, your first step is going to be factoring out that largest common factor as usual. Then you want to multiply the leading coefficient A with the constant C. Like I said, the A and the C get multiplied together. We want to find factors of AC that sum up to B. So we're going to multiply these two together. Their factors should equal B. And then what we're going to do is we're not going to all of a sudden have our factors. We're going to split up this B according to the factors that we found. And then we're going to do something called factor by grouping. And then, of course, you can check this to make sure that everything works. So this is going to be the first example. Or actually, I think it's my only example, and then I have you work on your own. So remember, this is ax squared plus bx plus c. So first thing we need to do is we need to take A and C and multiply them together. So A would be 4, C would be 15. This is going to give me 60. So what I need to find is factors of 60 that are going to sum to that 15 in the middle. So we got 1 and 6, we add those together. Like I said, everything here is positive, so we only need to worry about positive factors. 1 and 6 make 60. If we add them together, we get 61. 2 and 30, we add those together, we get 32. We got 2 and 30. What was the other one? 3 and 10. No, not 3 and 10. 3 and was that 20? There we go. I'm trying to look at the wrong number. That is going to give me 23. Then we have 4 and 15. So if we add those together, I'm going to end up with a 19. Then I have 5 and 12, which is going to give me 17. All right, and here we go. Last one. 6 and 10. Those add together, give me 16. So those are my two factors. So what I'm going to do is I'm going to take 4x squared plus 16x plus 15, and I'm going to break up this middle term, so it is going to be broke up into 6 and 10. So what I mean is I'm going to write this as 10x plus 6x plus 15. I could have wrote 6x first and 10x. It's not going to make a difference here. Then, like I said, we were going to do this factor by grouping. So what that means is if we got 4 terms like this, or an even number of terms, we pair them up. So we're going to put these two together, and then we're going to factor out a greatest common factor that we have. So in this case, both of these are divisible by 2 and x. It's my greatest common factor. If I factor it out, I'm just left with 2x plus 5. Over here, if I look at these two, I can factor out a 3. If I factor out a 3, here we go. I'm going to be left with 2x plus 5. Thought I had something wrong there for a second. So what we should notice right about here is that I have factored out the same binomial right here in each case. So this is multiplied on. I can factor out that binomial of 2x plus 5, and I'm going to be left with 2x plus 3. So we can always check to make sure that worked. I'm going to write it over here quickly. Are these the correct factors? Let's see. So distribute here, I get 4x squared plus 6x. Now I do this distribution, I get 10x, and then this one I get 15. Yes, those factors worked. So the factorization of 4x squared plus 16x plus 15 is going to be 2x plus 5, 2x plus 3. So I like AC method because it's very, very quick to get through these calculations, and you're not trying to do all this guess and checking. The guess and check can work pretty quickly if like there are not a lot of factors. These like we got 4 sets. We got, like 1 and 4 and 2 and 2 are the sets of factors that I have. If I look at 15, I got 1 and 15, and then I got 3 and 5. So there's not a lot of combinations of factors. So this one may not have been a bad idea to use the guess and check method on. But like I said, certain cases, as one you're going to see here in a bit, the AC method is much more helpful. So take a moment and try number 10, number 11, number 12, and number 13. So remember, 13 is that one that we did that we had, I think we said like there's 48 probably different combinations I think I came up with of moving around factors trying to figure it out. We're going to try that with AC method. So it's ones like this we really need AC method for. But always check first. Oh, I don't think so. I don't think none of these have an AGCF to factor out. So like I said, just try that AC method, see how it works, and then come back and we'll go through it together. All right, so hope you had a chance to work on these and it went well. So we got 2x squared minus x minus 6. So the A is the 2, the C is the negative 6. We multiply those together, we get negative 12. So we're going to have negative factors to consider here. So factors of 12 would be 1 and negative 12, negative 1 and 12. And then we would have 2 and negative 6, negative 2 and 6. And then we would have 3 and negative 4 and negative 3 and positive 4. So if we add those together, 1 plus negative 12 is negative 11. Negative 1 plus 12 is positive 11. Where were we? 2 plus, or 2 minus, or 2 plus negative 6. Either way is negative 2, negative 4. Negative 2 plus 6 is a positive 4. 3 plus negative 4 is negative 1. And then negative 3 plus positive 4 is a positive 1. So we were looking to get this term in the middle. So we needed a negative 1. 3 and negative 4 give us that. So at this point, we are just going to rewrite 2x squared minus x minus 6. And we're going to break up that minus x into a minus 3x. Oh, sorry, a positive 3x. So we had a positive 3. And a minus 4x. So we know if we sum those together, we're still back to a negative x. So we're going to do this in groups. So these two, the only thing I could factor out of 2x squared and 3x that's the same is just the x. So I'm going to be left with 2x plus 3. Now for these two, I can factor out a 2, but they both have a negative. So I'm going to factor out a negative 2. So if I take out a -2, I'm just going to be left with 2x here and a +3 here. So it's just changing these into positives by factoring out that negative. Both have the 2x plus 3. It's one of their binomial factors. I can factor that out, and then I'm just left with the x minus the 2. So if you got a little stuck in the negative, that's okay. You have some time to practice that. As I keep telling everybody, it's okay to make mistakes, because when you make mistakes and you notice the mistake, that is something you remember. So mistakes are actually a good thing for learning. They show you things that you know you have to work on, and when you work on it, for some reason it sticks in your memory much better. Right, so for number 11, A is the 8, C is the -3. We multiply those together, we are going to get a -24. So I need factors of -24. And I need just make sure that sum of those factors is going to give me 2. So I'm pretty sure like the 1 and 24 and things are not like that are not going to work. But what I think could work is maybe 6 and 4. One of them have to be negative. All right. So if we sum these up, 6 plus a -4 is a +2. -6 plus 4 is a -2. So these would be my set of factors. So we're going to take 8x squared. We're going to turn 2x. We're going to split it using these factors. So we'll have a +6x and a -4x minus 3. Okay, so we're going to end up factoring out a negative again. So once again, if I do these two together, well, both of them are divisible by 2 and an x. If I factor that out, I'm just going to be left with 4x plus 3. These two, I can factor out a negative. So essentially, I'm factoring out a -1, and I'm just left with 4x minus 3, or plus 3, sorry. If I factor out that 4x plus 3, so you should always make sure like this term turns out the same. If it doesn't, it may be you need to factor out a negative. That's usually going to be tripping you up. It's just those negatives, so just watch out for them. But this should always work that you end up with the same binomial here. If it didn't, then that means you had to factor out a little bit more when you were doing this little group factor by groups. But anyways, I'm going to be left with a 2x minus 1. So 8x squared plus 2x minus 3 is going to be 4x plus 3 times 2x minus 1. Just sit here checking quickly. 6. Yep, that should work. All right, so then 12, A and C, so we get 6 minus 6. AC is -36. So I need factors of -36. And then I want to know what the sum of those factors is. So what we want to make sure is that I'm going to get a 5. So we're pretty sure the 6 and 6 is probably not going to work. So what you might want to do is just start, like I said, you might want to think on it a little bit and kind of figure out which ones are worth our time. Like we're pretty sure those ones aren't going to work for us. The 2s are probably not going to work for us. If I divide by 3, the 3s are probably not going to work for us. So you can go through all these, but what we're going to get is a minus 35, positive 35, then we get a minus 16, a positive 16. Let me see, negative 9, a positive 9. So next set of factors are going to be, I'm going to have to erase these so we have room. So we tried these, none of these worked. So starting at 3, I'm going to start with 4 next. So if I divide 36 by 4, I get 9. So I have the choice of 4, negative 9, negative 4, and 9. That gives me a negative 5. These two together give me a positive 5. So it looks like these two are going to be the ones that are going to work. The other set I could have used were the 6s, but like I said, we know that's going to result in a 0. So we take 6x to the 4th plus 5x cubed minus 6x squared. So I don't know if anybody noticed the extra powers here. So if you get stuck with them, don't worry. If you didn't factor something out all the way, I'll show you what to do here in a minute. So we should have noticed that we actually could have factored out a x squared from all this first. I said, if you didn't do it, that's fine. We're going to show you what happens if you don't do that. You're not like stuck on your problem and have to start over. We're still okay. So here, if I do this grouping, we notice that both of those are divisible by 3 and x cubed. So I can pull that out, and then I'm going to just be left with 2x plus 3. Here, we got 2 negatives. I can pull out a negative 2 and an x squared. If I do that, I'm just going to be left now with a positive x plus 3. 2x plus 3. It's going to leave me with 3x cubed minus 2x squared. So if you had a question like this and you got stuck and this wasn't working, and you're sure that you did everything right, go back and see, is there something I can factor out here? No. Is there something I can factor out here? Yeah, actually there is. There's a, I can factor an x squared here. So I'm going to actually just write this way for a second. So I'm just flipping my two binomials because they're multiplied together. So I could just factor out the x squared. So I just want to mention this because this is bound to happen, is that you're going to not notice that you could have factored out a GCF. In this case, it was that x squared. If you didn't notice that and you get some answer and you put it in and it's not working, like I said, go back, make sure that there wasn't something that could have been factored out of one of these binomials here. In this case, like I said, we could have factored out that x squared. All right, so this was the nasty one that we had before. So we're going to show you how I had done it and how I kind of knew what to pick there. So in this case, I had my A is 18 and my C is negative 12. My AC is a negative 216. So I need factors of negative 216. So of course you have like 1 and 216 and 2 and 108. try to think of, like the ones you can eliminate really quickly, like that, like those. Or you'd have 3 and 72, because what we know is that we want them to have a sum of negative 19. So you want to pick some numbers you know are going to be closer together. So let's say you started with 8. Factors 8 divides in there and would leave you with a negative 27. Or you used a negative 8 and you had a positive 27. Or maybe 9. Those are some numbers that are pretty close together, 9 and 24, close enough that maybe you look at them and go, that could be 19. So all I did here is there were tons of other factors I can look at. I'm just picking the ones that look like they're close enough together that their sum would be a negative 19. Like if I divide by 6, I believe that was 6 and 36. I know that's not going to be close to 19. So that's why I look at 8 and 9. So if you do these two here, 8 and 20 plus a negative 27, that's a negative 19. Negative 8 plus 27 is a positive 19. 9 minus 29 is a negative 15. And then next one would be a positive 15. So like I said, that's kind of why I picked those factors, because they were close enough together. I thought this might actually, give me the kind of answer I'm looking for. But we see right here, 8 and negative 27 are giving me that minus 19. So I had 18 m squared. And then that negative 19 mn, I'm breaking into a positive 8 mn and a negative 27 mn. And then I'm getting minus 12 n squared. So from here, both of those are divisible by 2 and m. Yep, which will leave me with a 9m plus 4n. Here, both of these have a negative, so we can factor out a negative. Both of them are divisible by 3 and n. So here I'd be left with positive 9m. And then here I'd be left with a positive 4n. After I factor out the 9m plus 4n, what's left is this 2m minus the 3n. All right, and that was how I figured out that last one, is I just did AC method to, and then like I said, I kind of cheated here on my factors. I want, all right, which ones are close enough to potentially give me negative, or give me a negative 19. So I just took negative 216 and I started dividing. Divide by 6, 6 and 36 weren't close enough. Divide by, well, it's not divisible by 7, but divide by 8, 8 and 27, they seem close enough to give me 19. 9, 24, they seem close enough to give me 19. So I just started dividing this, like I said, by numbers. So like 1, 2, 3, 4 is going down and looking for those factors quickly. But that is my answer right there.